Hey guys, I just wanted to come on and talk a little bit about entropy. I know it can be a little bit confusing, so I just wanted to clarify a couple things. Okay, so entropy is going to be the randomness or the disorder in a system. Okay, and a system can be anything you are looking at. So if we have our picture up here, I could say that my whole left side of the screen is one system. That's what I'm looking at, okay? The right side of my screen is going to be another system. And if entropy is the amount of disorder or of randomness, okay, you can see on the left side over here, these circles are all lined up really nice and neatly. There's a pattern there, okay? And so because of that, they're not very random. So that would be a really low entropy. On the right side, there's no pattern here, okay? It's very random or very disordered. So that would have a high entropy. And the thing to keep in mind, other thing to keep in mind, I should say, is that according to our second law of thermodynamics, entropy in a system, if it's left alone, will always increase. So it wants to go from this left side to the right side. Okay? And that's going to be the whole universe as well. If we look at the universe as a whole, entropy will always increase. So a couple examples to hopefully help it make a little bit more sense. We have these two pictures of some dorm rooms. Okay, the girl on the left over here, very neat, right? Everything's put away where it's supposed to be, everything's organized. Okay, it's very ordered. So that would have a really low entropy. The girl on the right over here in her room is a little bit of a pig pen. Okay, so this would be very high entropy. Okay, everything's thrown everywhere, there's no sense of organization. Okay, you don't know where anything's going to be. So the right side would be high entropy, this would be low entropy. Okay, and again, if we go back to that second law of thermodynamics, if you have a nice neat room like this on the left and you never put any energy in to cleaning up your room, okay, you just let it be. You let our system, which is your room, be on its own. Okay, eventually this room is going to look more like this messy one, right? If you don't spend any time cleaning your room, it's going to be a mess. So that would be like the second law of thermodynamics, right? You leave the system alone, you don't put any effort into cleaning, you're going to end up with a mess. That's the second law of thermodynamics. Okay, to get it back to our nice low entropy organized room, you need to put in energy, okay, to get it back to that low entropy state. If we want to talk about this in a more scientific application, if we think about our three states of matter, okay, we have solid, liquids, and gases. Solids, you guys know the particles of solids, right? They're packed really close together, they don't move around a lot, it's very ordered. Okay, you know where a particle in a solid is going to be because it doesn't move around very much, it just vibrates in place, right? So this, our solid, would have really low entropy. Liquids then, okay, they can move around a little bit more, right? They can slide past each other, but they're still kind of contained in their certain volume. Okay, so they're going to have a little higher entropy than our solids, but they're still going to have a lower entropy than our gases. And our gases, again, we know gas particles can go flying everywhere, right? They're bouncing off of things, bouncing off of each other. It's all kind of crazy and very random, which means they have a really high entropy. Okay, so as you change states from solid to liquid to gas, you would be increasing your entropy. So that's just a couple quick examples. Hopefully this helps and we can get entropy figured out.